Hi friends, welcome to follow up. In this video, I'm going to explain problem 100, a theme tree. This is an easy problem, but we want to use this problem to explain a very classic technique in coding, that is recursion. And also, we regard this video as a starting point. So the basic plan is that we are going to talk about these problems. Problem 543, problem 1522, and the problem 208, and the problem 3045. So the topics are on tree data structure. So actually this problem 100 and the problem 543 are on binary tree, and the problem 1522 is on n-ary tree. So the last two problem 208 and 3045, are also on trie abstract data type. So they can also be regarded as n-ary tree, right? So starting from this video, we want to understand some basic concepts or technique when we do problems related to tree, right? So first, before we do this problem, I want to mention that the recursion is a technique. It's widely used not only for applications with tree data structure, but also other cases, actually very wide. But here, because the tree data structure can be defined in a recursive fashion, it naturally suits the paradigm, I would say. Or we can see there are some natural connection between recursion technique and the tree abstract data type, right? So without further ado, let's look at the problem statement. So here we are given the roots of two binary trees P and Q. We want to write a function to check if they are the same or not. So two binary trees are considered the same if they are structurally identical and the nodes have the same value. So there are two aspects. One is structure, right? So in mathematics, if we see something structurally identical, we can see they are sort of isometry, right? Or isometry is related to some distance, some metrics, or we can see it's isomorphic, right? Something like that. It's not in a very rigorous sense. And the nodes value are the same. This is very easy to digest, right? So let's look at the three examples. So in the first example, so both the two trees are actually, you can see one looks like a copy of another, right? So we return true naturally. And the second one, we are going to return false. The reason is that if you look at the root that with a value 1, they're the same. However, for the first tree, they have a left subtree, a single node left subtree with root value 2. Well, for the second one, it has no left subtree, but it has a right subtree with the root value 2, right? So they are not structurally identical. This is the third one. So if you just ignoring the node values, so structurally they are the same. However, their node values are not the same. For example, if you look at the left subtree for the first tree, it has value 2 for the root. Well, for the second one, it has value 1, right? So in both example 2 and example 3, if you do a symmetric line in between the two trees, it looks like one is this image, miracle image of the other, right? But they're not identical trees. So here the constraints are the following. The number of nodes in both trees is in the range given by a closed interval 0 and 100. So here notice that the two trees can be null, right? So actually later you will notice that even the trees, both trees are not null, we still need to include the null case as a stop condition in the recursion. So here the node value is in this range. The absolute value is bounded above by 10 to the power 4, right? But the value can be negative, can be 0, can be positive. So with that said, we are ready to look at coding. So well, for the coding, actually, it's rather straightforward here. So here, let's first recall a recursion. So there are three ingredients in the recursion. First is base case. Some people also call it a stop condition. So I would say base case typically is a stop condition, right? Stop condition is more wide than base case. It's better to speak of base case in the case of recursion. And the second is self-call, right? So typically, if you write a recursion function, right, you need to do self-call for the function itself. So this is another thing. Another thing, the third one is that so move towards the base case, right? So that's the three ingredients. So this move towards the base case actually corresponding to decompose the problem into smaller ones. So now with those said, let's look at the problem here. First, I can write a stop condition. Let's see, stop condition or conditions, right? Or stop case. So this is much better. So first, if not P and not Q. So this means the two trees are both null. So in this case, we should return true, right? This is very easy to digest. And then the complement of this condition is that either P or Q. In other words, at least one tree is not null. And then we consider the complements. The two cases, for example, is the one tree is not null, but the other tree is null. So in these cases, we should return false. So this also can be regarded as base case or base stop conditions. Let's see, base case. So let's see, I write it like this, not P and Q, or not P and not Q, right? So this condition basically covers the case that one tree is not null, while the other is null. In this case, for sure, we need to return false, right? So then if we write else, so this corresponds to the case that both P and Q are not null trees, right? Then we just need to use the definition here, right? Two binary trees are identical if they are structurally identical and the nodes have the same value. First, we need to check. So if the tree has same value, so if P value, right, equals Q value. The reason we can write this if condition is that within this else block, both P and Q are not null, right? Therefore, we can access this value field or attribute. And then in order for them to be identical, we need the left subtree and the right subtree to be identical respectively, right? So what we want to do, we do self-call, right? Self is symmetry. Then we do P left, right? And Q left. So because this function will return a Boolean, so this is also Boolean conditions. It's another and. Self is sim. So we do P right and Q right, right? So if these three parts of conditions hold, then we're going to return true. And otherwise, so you can write else or not. It depends on your coding style. So just return false for all the other cases. So this will cover all the cases, right? So you can regard the first two parts as base cases. And then, so here is the self-calls, right? Because we have, now we consider the subtrees. We work towards the base case or base cases, if you like. So now let's do a test quickly. It passes the first one. Now let's look at the generic case. It passes all the generic cases. So with that said, I guess we finished our beginning practice. So next I'm going to look at problem C 543, right? So here I want to make a comment. So this is just one way of writing this this solution. There's a lot of variants you can try, right? So here I'm writing in a recursive format. You can also try to write in iterative format. For example, you do depth first search, and then you in the process you consider if they are the same and also corresponding to the same value, and you can invoke some early stopping conditions. So that's also good. But here, for our to be consistent for this series of problems, here I just present this recursive solution. So with that said, I guess that's it for the current video. Thank you for watching.